Alright, so today I'm going to be going over this article over at edge.org. It's an article by Amanda Gefter, who's claiming to be a new scientist, but as you'll see in this article, and as I will explain to you, this concept of structural realism that she's trying to explain, that she's trying to uh, promote here at edge.org, is completely irrational. It has nothing to do with science. It has nothing to do with any explanations. I mean, it might be deep and elegant or beautiful to her, but it's not rational. It has nothing to do with rational science, physics. It has nothing to do with any of that, and I'll explain exactly why going through this article line by line. So, it starts off by telling us about structural realism. Structural realism, in its metaphysical version, championed by the philosopher of science James Ladyman, is the deepest explanation I know because it serves as a kind of meta-explanation, one that explains the nature of reality and the nature of scientific explanations. So you can already tell that this is sophistry. You can tell that this is not actually science because instead of talking about the real, the actual concept of explanations, which is an account of how or why something happened, she's talking about explanations of the nature of reality or the nature of scientific explanations. It's nothing in particular. She's not explaining why the Earth moves around the sun. She's not explaining why um, two magnets pull each other together. She's not explaining any particular phenomena. She's saying that it explains these general, vague, uh, lofty, foggy. They're so vague. The most vague concepts you can think of: the nature of reality and the nature of scientific explanations. And how can you explain explanations? How does that make any sense? An explanation is how or why something happened. How can you explain what an explanation is? You have to define what an explanation is. You can't explain what an explanation is. That's circular. You have to define what you mean by the word and move on from there. That's all you can do. So already this is talking about these supernatural, almost grandiose, but extremely vague concepts like the nature of reality and the nature of scientific explanations. Not science. Um, Next, it says the idea behind structural realism is really pretty simple. The world isn't made of things. Okay, so it's not made of things. It's made of mathematical relationships, which obviously this begs the question, relationships between what? What is a mathematical relationship between? How can you have a relationship without two or more things to relate? There's no relationship without the things you're relating. Um, and isn't structure a synonym for a thing? Isn't or at least it's a synonym or it refers to things. Like my cells have structure. The earth has structure. The galaxy has structure. So structure is something that is going to evoke things or objects, physical things, by definition. You can't have structure without physical things. But they're going to say that a mathematical structure is a set of isomorphic elements, each of which can be perfectly mapped onto the next. Okay. To give an example, 25 and 5 squared share the same mathematical structure. So mathematical structure is obviously just tautology. It's just a definition. 5 squared and 25 are equal by definition, not because they share some structure. That makes no fucking sense. What they share is an equivalency by definition. They're a tautology. There's absolutely no difference. They're two symbols meant to refer to the same exact concept. And so 5 and 25, saying that they share the same mathematical structure, is once again vague and rhetorical and sophisticated. It has nothing to do with science. And in reality, if you really want to understand why 5 squared and 25 are equal, it's just because it's a tautology. It's been defined. It's been predefined that way. That's why the reason that they're equal is because we say so. It's because that's the system that we've defined. But continuing on, when the philosopher John Worrell first introduced structural realism, though he attributes it to physicist Henri Poincaré, he was trying to explain something puzzling. How was it possible that a scientific theory that would later turn out to be wrong could manage to make accurate predictions? It's a good question. How is that possible? So she's going to say that the reason it's possible is because there's some mathematical structure. But in reality, the reason it's possible is because humans have pattern recognition. When we see an event occurring, like say we see the sun rise every morning in the east, and we see this day in and day out over and over and over again for years and years, we begin to project that event from the past onto the future. That's what we naturally do. This is an instinct for humans to take what happened in the past and try to project that onto the future. And we can describe the event mathematically. We describe how long it'll take for the sun to rise, or um, how bright the sun is at certain points in time when it's rising, or the colors that it's producing, or whatever. We can describe these things, and we can describe them mathematically. But the fact is that being able to make this prediction that the sun will rise tomorrow doesn't mean that we understand why or how the sun is rising. We don't understand that the earth is actually spinning. I mean, we do now, but not necessarily. People used to understand, okay, the sun's going to rise tomorrow. They used to be able to predict that, but they never understood how that was happening or what was causing that to happen. They didn't understand that the earth was spinning, that the sun was relatively stationary, that we're swinging around the earth, or we're swinging around the sun. They don't understand these mechanisms, and those mechanisms are exactly what science is meant to figure out. Science is meant to tell us how or why the event occurred. It's supposed to explain the cause of what is mechanically operating to or for this event to occur. So clearly predictions have nothing to do with the scientific method. Predictions require no understanding of the mechanisms involved in any event, and it's no more than guessing the outcome of an event. Science is about explanation, or telling how the event occurred, which prediction has nothing to do with. Okay, so moving on, it says Newton said that gravity was a force that masses exert on one another from a distance, but that idea was overthrown by Einstein, who showed that gravity was a curvature of space-time. Given how wrong Newton was about gravity, it seems almost miraculous that he was able to accurately predict the motions of the planets. But it's not miraculous. How is that miraculous? We watch the planets move. We watch it over and over and over and over again, and then we just put that past event, we overlay it onto the future. And usually that works. But that doesn't mean that we understand the mechanism or the physical structure, the physical object, which keeps the planets from flying away from each other. Why do planets orbit each other? What is extending between the two planets to connect them? She hinted at these ideas like there was a force or there's a curvature of space-time. But these ideas, as she's going to admit in the next paragraph, are just stories. They're models, and they're irrational models at that. There's no such thing as a force. Force is, as she will explain later, a description. Force is a mathematical description. It refers to a concept. There's no thing in reality called force. And it's the same way with the curvature of space-time. It's nothing more than a mathematical object, not even an object. There's no such thing as a mathematical object. It's a mathematical concept which is describing the motion of the planets. There's no such thing outside of the Earth called space-time, like a big wall of space-time, which we're rolling across or something like that, because it's not a thing. There's no thing called space-time keeping us bound to the sun. So she's essentially making my argument for me. She's using pseudo objects and not giving any explanation as to why the Earth goes around the sun. She's saying that all of these explanations are essentially equal because we can make accurate predictions. So, continuing on. Thankfully, we don't have to resort to miracles. Newton may have gotten the physical interpretation of gravity wrong, but he got a piece of the math right, see? That's why, at weak masses and small velocities, Einstein's equations reduced to Newton's. The problem, Worrell pointed out, was that he mistook the interpretation of the theory for the theory itself. The fact is, in physics, theories are sets of equations, and nothing more. Quantum field theory is a group of mathematical structures. Electrons are little stories that we tell ourselves. So really there it is. Honest and open. These guys, or at least this chick, the structural realists, are not interested in visualizing physical objects. They're not interested in visualizing the mechanisms responsible, such as like an electron. Even if we assume that the electron exists, at least it's supposed to have shape, at least it's supposed to be a little bead, which is better than saying that mathematical objects or mathematical concepts exist. But it's taken the entire history of mankind to try to explain events like gravity, magnetism, electricity rationally, but nobody's been able to, so these guys are just giving up. Since we go from forces to curvature of space-time and electrons, all we have to offer, or all these guys have to offer, are irrational, unimaginable pseudo objects and pseudo mechanical theories. Since that's all they have to offer, they're just going to give up and say, well, we're not even going to try to give you physical objects anymore. We're not going to use the physical objects. We're just going to say that it's all math from here on out. So the moon, I guess, is a mathematical structure, according to them. So from here on out, it's all math. Nobody wants to imagine what an electron looks like. Nobody wants to imagine what an atom looks like. Nobody wants to imagine what is mediating light. Nobody wants to visualize how the sun sends its light to us, or how the sun keeps us swinging around its belly in orbit year after year. But why not just admit that they can't figure it out? Why not just admit that they're stumped, that they tried to use the idea of force. Okay, they tried to use force, they tried to use space-time, they tried to use electrons, they tried to use these sorts of objects, but all of them fail at a ridiculous level. You can't visualize these mechanics, you can't understand these mechanics, so they go straight back to the math. Say, okay, well then it just works because that's mathematically sound. They don't use any mechanical reasoning anymore, as she's about to say very openly. These days, believing in the reality of objects, of physical things like particles, fields, forces, and even space-time geometries can quickly lead to a profound existential crisis. So there it is. She doesn't want you to believe that objects exist. You don't exist. I don't exist. The Earth is not an object. Uh, the moon is not an object. Um, they don't exist. All it is a mathematical structure. That's what they want you to believe. Um, and I mean, the people who have bought that, I can imagine how they would be having existential crises. Uh, Quantum theory, for instance, strips particles of any sense of thingness. One electron is not merely similar to others. All electrons are exactly the same. Electrons have no inherent identity, a fact that makes, how could they be the same? They have no identity. Well, a fact that makes quantum statistics drastically different from the classical kind. Quantum statistics. So we're not even doing physics. Anyone who believes we're doing statistics. Anyone who believes that an electron is a thing in its own right is bound to lose big in a quantum casino. But they just said that quantum objects were little stories that we told ourselves, right? So these quantum objects are just little stories. But now these little stories are completely stripping supposedly real objects of their thingness, right? Quantum theory strips particles of thingness, but the particles are just little stories. So I don't understand. How are these little stories changing what's happening in reality? But we should back up a little bit and try to understand what makes a thing a thing. We're talking about thingness here. What is it that makes a thing a thing? Um, Objects like the electron, like space-time, or supposed objects. Space-time is not an object, but supposed objects, they should have shape. So like the moon, the sun, an electron, these these sorts of things, particles, these sorts of things should have shape. That is what defines an object. Even Aristotle said the essence of a thing is its form. Without form, there is no object. Now, not all objects exist. I mean, there are imaginary objects like Superman. He has shape. Superman has shape, but he has no location, so he does not exist. There are ideal objects like a circle, which has shape, but there's no such thing in reality as a perfect circle. But the term exist can only refer to objects. Even if some objects don't exist, exist can only refer to objects, and specifically objects with location. If a thing exists, then there should be a distance between the edge of that object and the tip of your nose. There's a distance between all existing objects in reality. They're all within the same spatial field. They all have a distance between each other because there's literally no boundary to space. There's no boundary to separate them in space. But anyways, that's a little bit of a digression, but you need to understand what makes a thing in order to comprehend why this is so ridiculous, why this idea in this article, such as like uh, the electron losing its thingness, makes no sense. A thing either has shape or it doesn't. If it has shape, it's a thing. If it doesn't, it's a concept. So it either is a thing or so they're trying to take all the things out of reality, even though it's just a little story. So these are kind of contradictions, uh, blatant contradictions that are within her own writing. But continuing on, she says, I'm going to find this quote. Meanwhile, all of nature's fundamental forces include electromagnetism and nuclear forces that operate deep within the cores of atoms, which, once again, core refers to shape. These sorts of things are talking about architecture, and yet they're not supposed to have architecture. So, contradictions all over the place. They're described by gauge theory, which shows that forces aren't physical things in the world, but discrepancies in different descriptions in the world. Okay? So this is a very important uh, concept to understand. A force, like gravitational force, magnetic force, electric force, whatever, they're not physical things. These are the descriptions. These are the descriptions. Um, things like, or concepts really, like gravity, forces, they don't exist because exist refers to objects. The Earth exists. The moon exists. The Earth pulls the moon. We call that gravity. That concept of the Earth pulling the moon doesn't exist. That's just a concept. That's what happens. So these concepts don't meet the requirements, these concepts like forces, they don't meet the requirements of existing. They're not physical things. They're just descriptions, concepts, events, occurrences, relationships. Physical things and exist really are synonyms. And they refer to objects with location. That's the definition because that definition can be used consistently without contradiction or circularity or ambiguity or anything. So exist is that which is physically present, an object with location. That is the only rational definition for the term. You exist, I exist, the Earth exists. Um, so here's an interesting. Gravity is a gauge force too, which means that you can blink it out of existence. See, this is what I was just saying. But gravity doesn't exist. So to say that you can blink it out of existence implies that it existed at some point in time in the past, just by changing your frame of perspective. So they're implying that it existed at some point in time in the past, but you can blink it out of existence based on your frame of reference. It doesn't work with any real thing. You can't change your frame of reference and blink the Earth out of existence. You can't change your frame of reference and blink the moon out of existence, because they exist, and existence is objective, independent of your frame of reference. It's completely independent, and um, so this sort of thing is just rhetoric to talk about blinking things out of existence. It's just it's meant to get you to accept wild and absurd things. Like this is just not thought through. You have to define the word existence clearly and consistently so that you don't end up saying things like this. You can blink gravity out of existence. You can't blink anything out of existence. Existence is independent of your blinking. It's independent of your frame of reference. And the reason that gravity doesn't exist is because it's the concept of the Earth pulling on the moon, or the Earth pulling on you, or the sun pulling on the Earth. It's a concept. We don't understand what it is that's pulling, so we use the word gravity as a placeholder to talk about it. We don't exactly understand what is pulling, so in order to talk about it, we come up with this subject called gravity. So moving on though. In fact, that was Einstein's happiest thought. A person in free fall cannot feel their weight, which once again argues my point that science has nothing to do with the observer. It has nothing to do with frames of reference or observation, because observation is dependent on the viewer, and every viewer is going to have a different perspective. So observation is by definition subjective. It's nothing to do with science. So let's move on a little. Recent advances in theoretical physics have made the situation worse. The holographic principle tells us that our four-dimensional space-time and everything in it is exactly equivalent to physics taking place on a two-dimensional boundary of the universe. Wow. Wow. So we need to just understand a couple things here. Form is a key concept in this discussion. We've talked about form when it comes to structure. We've talked about form when it comes to force. Force has no form. Curvature of space-time has an irrational form, something you can't visualize. Electrons should have form if they're objects. all objects have form. We've talked about this. But now we're going to talk about dimensions. Okay, 'cause this is important. The holographic principle. A lot of this has come up recently in science. Um, so we need to understand that dimensions refer to the architecture or the form of an object. Dimensions refer to form. They refer to shape, architecture. I don't know how many other words should I use for this concept to be understood, but that's what it refers to. Dimensions are length, width, and height. But in mathematics, they've redefined the term to mean coordinates. And a coordinate is just a numbered pair. It points to a certain location. It points inward to a certain location. You can have as many coordinates as you could possibly imagine, which is why, I mean, a paragraph down, starts talking about 11 dimensions. It's nuts. There's 3 dimensions, and the reason for that, there's a reason, is that length, width, and height are all orthogonal to each other. Here, I'm going to find a picture. Length, width, height. Okay? See, the reason that we have length, width, and height is because they're all orthogonal at right angles to each other. Length, width, and height all are at right angles to each other. They sit at 90 degrees. They're orthogonal. And they point in certain directions. They all have a direction. They all sit right angles to each other mutually, so they all are at right angles to each other. And they point in certain directions. Okay? That's why we have dimensions. That's why there's 3 dimensions. No more, sometimes 2, but that's an imaginary thing. But certainly no more than 3, no less than 2 is possible. Because it's because no axis could possibly sit at a right angle. Again. Nothing could possibly sit at a right angle to both length, width, and height, to all 3. It's impossible for there to be a 4th direction at right angles to all 3 of these directions. It's impossible. No axis could possibly perform that function. Therefore, no 4th dimension is possible. Um, two-dimensional objects, like she's talking about here, um, the two-dimensional boundary of the universe, they don't exist. A two-dimensional object is imaginary. The only real things that exist are three-dimensional. You have to have 3 dimensions for it to have location. So this is complete nonsense. And also, to talk about the boundary of the universe is a concept. The universe refers to matter in space. Space has no boundary. Concepts have no boundary. So, since space is included in the universe, there's no boundary to the universe. There's no wall of space. Space has no border. It's boundless. It has no shape. So there's no way for there to be a boundary of the universe. This entire statement here is the most ridiculous statement in probably the whole article. It says neither description is more real than the other. And the author puts real in quotes, which is very telling, because she probably has no rational definition for the term. She's used the term real, she's used the term exist, she's used the term physical things, existing, somewhere up here, you can find it. She's used these terms but hasn't defined a single one of them, so that's why she's put real in quotes. She doesn't really understand what she's talking about. Moving on, the physical nature of reality has further been eroded by M theory, a theory that many physicists believe can unite general relativity and quantum mechanics. M theory encompasses 5 versions of string theory. Um, blah blah blah. This is mostly nonsense. Virtually any object you can think of will be transformed into something totally different as you move from one theory to the next. And yet, somehow, all of the theories are equally true. These are her words. Somehow, somehow, yet somehow. That's how we're supposed to understand. Um, Clearly, she learned this trick from the old quantum magicians who turned particles into waves. So now they're turning strings into particles before they turned particles into waves. I wonder what they'll be turning next. The but thankfully this only happens in virtual particles. Uh, but this brings me back to what she said about the electron itself. She said that electrons are just little stories, little stories, and I'm going to assume that it's the same way with these strings and particles because it's not just the electrons. They're talking about in all of physics, these theories are just equations. So the visualizations that we get, the actual architecture and structure that's being proposed, those are the little stories. The uh, mathematical equations, those are the real physics. So I'm going to assume that even down here, when we're talking about how strings are changed into particles and blah blah blah, those are just little stories too. These are just the interpretations of reality that she's so vehemently against. Uh, so how is this supposed to erode the structure of the physical nature of reality if all of this is just a little story to begin with? If this doesn't really happen, if it's just a story that we're told to uh, model this event or to try to wrap our feeble little brains around it, that's just a story, then how does it actually impact reality? How does it actually change the physical nature of reality, erode the physical nature of reality? You know what? In reality, in the real world, oceans, air, dust, people, the sun, those things erode physical nature. Like the river erodes the riverbed, or the sun erodes paint that's painted on a house or something. These are physical things that physically erode reality. So these people speak nothing but in metaphor. They use their metaphors uh, as analogies at some point. They use them metaphorically at one point, and then later on it becomes literal. So they change from metaphor to literal whenever it suits them. They change from concepts to objects whenever it suits them. Whenever they want to make their theory seem more fantastic and more uh, inspiring or interesting, they'll switch from one thing to the next for no reason, whenever they want. But let's continue on. The reality crisis has grown so dire that Stephen Hawking has called for a kind of philosophical surrender, a white flag that he terms model-dependent realism, which basically says that while our theoretical models offer possible descriptions of the world, we'll never know the true reality that lies beneath. Perhaps there is no reality at all. But isn't it kind of a stretch to go from we'll never know to perhaps there is no reality? How is that possible? How is it possible that reality is not real? How is that possible? Explain to me how physical nature is not physical. How can we how can we even offer up such contradictory nonsense, incoherent babbling where we're just contradicting ourselves? How has this become like mainstream intellectualism? How has this become what most people are willing to accept about reality? It's just unbelievable to me. Um, and you know what? this kind of, I do agree on some level that theory is only offering possibilities. Theory is essentially where we work out the possibilities. In science, we can never declare that one theory is proven or 100% certain or 100% validated, but we can at least determine when a theory is completely incoherent. We can at least use reason to determine whether or not what you're saying is rational and coherent and understandable. Um, it's so simple to understand how things like M theory and general relativity and quantum mechanics, these these three theories here, it's so easy to understand why those are irrational. They turn concepts into objects. They think that mathematical things exist. The actual objects that they promote, that they assume exist, they back out at the last moment and say, well, no, they don't actually exist. They're just little stories. So they're covering all the bases. They have no theory. What they're doing is they're just trying to predict the future. They're trying to use past events to predict future events. They don't care about understanding reality, as this article has already completely exposed. That these people don't care about understanding reality. Um, so, the point is that even though we can only determine what's possible, even though we can only understand possibilities, we can still rule out irrational nonsense like quantum and M theory and uh, general relativity. We can rule these things out because it's just not possible. It's not possible for there to be shapeless objects. It's not possible for mathematical relationships to exist, period. It's not possible. So, and it's not possible for math to pull the Earth and the sun together. It's not possible for math to pull magnets together. That's not, math is a concept, it's an abstract idea. It doesn't exist. Um, so continuing on, structural realism offers a way out. A way out. An explanation, a reality. But the only catch is that it's not made of physical objects. So once again, reality is not made of real objects. Uh, Physical nature is not made of physical objects. Reality is not real. This is what passes for science these days. Then the author even reiterates: electrons aren't real. Gauge forces aren't real. Dimensions, geometries, strings, not real. What's real are the mathematical maps that transform one string into the other, one string theory into the other. So mathematical maps transform theories. You understand how this is not physical, this is not literal, this is just complete metaphor. This doesn't happen in reality. There's no such thing as a mathematical map, and there's no such thing as a string theory to be transformed. Like, I could transform uh, a, a pile of Legos into an amazing Lego house. That's a transformation. But mathematical maps cannot transform theory because they're both concepts. They don't exist. Transformation occurs in reality. So this is all metaphor once again. And, and they're trying to take this metaphor and say that in reality, there's nothing but math. Math exists. Can you imagine this? Like, how can people even begin to try to understand this? Or so the moon is a mathematical theory, I guess. The moon is a mathematical equation. I don't know, I guess. Um, and they go on. Of course, it's only human to want to interpret mathematical structure. There's a reason that 42 is hardly a satisfying answer to life, the universe, and everything. So, first of all, now that we're at the end of the article, say a few things. The phrase mathematical structure is contradictory. It's a self-contradiction. structure relates to objects, math relates to concepts. There's no such thing as a mathematical structure. Structure has form, refers to objects, but earlier she took all the objects out. No objects. It's not made of physical objects, but now there's mathematical structure. So she takes the objects out, she tries to sneak them back in. This contradictory language only serves to confuse you. She then goes on to talk about 42, which is a reference to a sci-fi novel, and this whole thing sort of reads like a sci-fi novel for like the most hardcore nerds who want nothing more than to project their crazy fantasies on reality. But like, because all of this stuff, this mathematical structure business, this uh, um, saying that physical objects don't exist, all of this stuff really is just leading to ideas like time travel and multiple dimensions, multiple parallel universes, or faster than light speed travel. Just like all of this is the bedrock. This unreality, this surrealism, is the bedrock of sci-fi. It's the bedrock of science fiction, and these people want nothing more than to travel to another dimension or to see their great great grandfather, great great grandmother, whatever, go back in time, go forward in time. They want nothing more than that. And so they want to justify these crazy fantasies as possible. They want to say that they're possible. So they have to start by first removing reality and substituting their own. They remove reality and substitute their own. Um, so moving on then. We want to know what the world is really like, but we want it in a form that fits our intuitions. No, once again, the word form has come up. The reason that we need form, not just a form that fits our intuitions, we need a form that will perform the actual function. We need a form where the function is going to follow from that form, as we claim it does. The form is the only cause of function. In reality, function follows from form. You can't have function without form. So form is central to explaining how things function as they do in physical reality. Any other type of explanation of phenomena is irrational or incomplete. A physical explanation, a physical theory, has to relate to form. It has to explain how form is relating to function. It doesn't just fit our intuitions. It has to rationally uh, follow. It has to rationally describe or explain why a certain function relates to the form and why that form is able to perform the function. Forms don't mean anything, but what they mean is that they're going to have a certain function, that it's going to be doing something in alignment or in consistency, being consistent with its own form. Um, so our narrative-driven brains, this is what she says, our narrative-driven brains, meaning comes in the form of stories about things. I doubt that we'll ever stop telling stories about how the universe works, and I, for one, am glad. We just have to remember not to mistake the stories for reality. But like I said above, we can never know for sure. I understand that. We'll never know for sure how things really work in reality, but our explanations need to be rationally reasoned at least. If you can't give a reasoned account for how something works, then you're not even trying to do science. This is the minimum requirement for any scientific theory, and this article has failed miserably at that. Also, this might sound a little nitpicky, but like I said earlier, no scientist can explain how the universe works, right? Like I said this about uh, explaining the nature of reality. You can't explain how the universe or how reality works because reality, the universe, uh, physical nature, whatever, These concepts are talking about matter as a whole. It's talking about a conceptual grouping, an abstraction. So it's not an actual thing to explain. It's not something with mechanical functions that you can explain. It's a concept, a grouping, an abstraction that doesn't perform functions. Okay, the universe itself, the concept of the universe, that itself doesn't perform a function because it is a concept. It's already a concept. It's a conceptual grouping. So you can't say that a conceptual grouping is going to do work in reality. So, but anyways, finally, structural realism forces us to radically revise the way that we think about the universe. It also provides a powerful explanation for the most mystifying aspects of physics. Uh, Without it, we'd have to give up on the notion that scientific theories can ever tell us what the world really is. And that, in my humble opinion, makes it a pretty beautiful explanation. But does it explain the speed of light? Does it, or the reason that the Earth pulls on the moon? Does it explain how two magnets push or pull at a distance? Does it explain how copper wires, if I put a copper wire here, it'll turn the TV on over there? How does it explain any of that? Of course not. Mathematical descriptions are not explanations. In fact, the author just got done arguing that since we'll never stop telling stories about how the universe works, we should remember not to mistake the stories for reality. But now, how have now mathematical descriptions have become reality? So first we understand that there is no reality, and then the mathematical descriptions become reality. It's unbelievable. Um, so this is the most backwards, confused state of mathematical physics today. It's all relationships with nothing to relate. All relationships, no things to relate. Uh, it's all number and no thing. Any child understands that numbers, like math, math is just numbers. A child understands that math, numbers, have no meaning without reference to things. If you don't believe me, go up to a person and tell them that you have three. Say, I have three. Or I'm looking for three. Can you give me three? I'll be like, three of what? Because three, if you go up to someone, I would like three, please. It has no meaning. Math only has meaning in relation to things. You have to ask three of what? So a common person can think more clearly and rationally than these super nerds who get lost in conceptual nightmares like structural realism. They believe that the moon is a concept. The moon is or your brain is a mathematical relationship. All of reality is mathematical relationships. This is what they want you to believe. So attempting to explain how reality works for them is off limits. But if you ask them, then they'll wholeheartedly tell you that they want nothing more than to explain reality. It's all just complete, utter foolishness.